mechanism we're going to talk about right now is called the renin angiotensin system, popularly abbreviated as what? The RAAS system, guys. It's called the RAAS system. People like mnemonics, RAAS system. The RAAS system. Okay, comparing the RAAS system with the baroreceptor system, you get to understand that what? The baroreceptor system, on the other hand, is a very fast mechanism, guys. This guy takes place the moment you have a cut. The moment you have a cut, this guy is trying to step up your blood pressure, guys. But this guy comes into play after this guy. You understand what I'm saying? That the RAAS system comes into play after the what? The baroreceptor system. Okay, looking at this particular renin angiotensin system deeply, it's kind of related to the what? To the baroreceptor system, or to the baroreceptor pathways. Because, like I was saying, the baroreceptor pathway has to come into play before the RAAS system. Okay, now look at it this way. If an individual have a cut, get me understand? That particular fellow has a continuous loss of blood from the body, guys. Okay, if he has a continuous loss of blood from the body, it means the closed nature of the circulatory system is compromised. And if the closed nature of the circulatory system is compromised, what happens? He has a decreased blood pressure. So, as the blood is being pumped out from the heart, to the aorta, from the large elastic aorta, coming down to the muscular arteries, understand? When it gets to the kidney, guys, when it gets to the kidney here, understand what actually happens is that what? Due to the fact that this particular fellow, he has a continuous loss of blood, so the kidney will be having a sort of a decreased perfusion. You understand what I'm saying? But guess what? The kidney is smart. It's really smart. Around the afferent vessels of the kidney, you understand? Just beside the afferent vessels of the kidney, now what is called juxtaglomerular apparatus, guys. You know what? These juxtaglomerular apparatus, they sense this particular low, the hypotensive condition of the flow of blood. You understand? So when this guy senses that the blood is flowing in a very low tension, you understand? And they know that the kidney usually works under kind of a high pressure on a condition, understand? You know, the kidney usually needs high blood pressure in order to carry out filtration. You understand what I'm saying? About 70 millimeters of mercury. So if the blood is not meeting up this demand, this juxtaglomerular apparatus, So this juxtaglomerular apparatus, like I told you, is located besides the efferent vessels. It has a macula densa. So this macula densa is the actual sensor, guys. It senses the hypotensive nature of the blood. So after sensing the hypotensive nature of the blood, what it does is that it usually sends signals to what we call the juxtaglomerular cells. You understand? Remember, it's juxtaglomerular apparatus which have juxtaglomerular cells, guys. Juxtaglomerular what? Yeah, exactly. They have juxtaglomerular cells. So these juxtaglomerular cells, they are what synthesize a very good fellow. That guy is called renin, guys. Renin. You understand? And this renin, this guy is a great guy. This guy, you understand? This guy called renin, what he does is that the liver. That's why I really like the liver, man. You can't live without your liver. So your liver usually synthesizes a protein which is called angiotensin, guys. Now, this renin converts this angiotensin, which is found in the plasma. Normally, when the liver synthesizes the angiotensin, it will release into the plasma, guys. You understand? You get the angiotensin in the plasma. So what happens is that as this guy renin is being released also in the plasma, this guy meets angiotensin. You're like, man, guy, we need your help over here, man. So you're like, you need my help? Yeah, exactly. So this guy converts angiotensin to angiotensin 1. You understand? Okay, now we have angiotensin. It's getting converted by renin what? Angiotensin 1. Tensin 1. And this guy over here, it goes to the what? To the lungs, guys. The blood takes this guy to the lungs. And in the lungs, what happens is that what? This angiotensin 1, it gets converted to angiotensin 2. Angiotensin 2 by what, guys? In the lungs, we have some enzymes called ACE. ACE, which means angiotensin converting enzymes. So, when this angiotensin 1 is being converted to angiotensin 2 in the lungs by the angiotensin converting enzymes, what does it do? It comes back to the kidney, guys. It comes back to the kidney. And in the kidney, what happens? What actually happens is that in the kidney, this guy goes to the adrenal gland. It knocks on the door of the adrenal gland. It's like, you're like, man, I need your help again. We need some aldosterone. We are losing some salt. We need some aldosterone. So the adrenal gland now synthesize aldosterone where? In the zona glomerulosa, guys, you understand? So in the zona glomerulosa, you get the aldosterone. Aldosterone, man. So what happened? This guy aldosterone, what it does is that it goes straight to the distal tubules, guys, distal convoluted tubules of the kidney. You understand? So when it goes to the distal convoluted tubules of the kidney, what happens there is that this guy now leads to the reabsorption of sodium, guys, and coupled with the release of potassium. It's like an exchange, guys. Sodium goes in and potassium gets kicked out. Sodium gets goes in. You understand? And normally the absorption of sodium, you understand, it goes alongside with the absorption of water. Look at it this way. The kidney is very smart. The kidney is really smart. When this guy here, when the guy he's stuck already, you understand, he's bleeding out, he's losing a lot of fluid, you understand, and so therefore the kidney knows that if sodium is being reabsorbed, you understand, water will also be reabsorbed, you understand. Therefore since this guy is losing fluid as a result of that, he's experiencing what is known as a decrease in intravascular volume, you understand. So when this guy is experiencing a decrease in intravascular volume, so by the kidney, guys, look at this, by the kidney reabsorbing sodium alongside with the reabsorption of water, it leads to an increase in the intravascular volume, because you accept you reabsorb sodium with water, guys, you understand. So therefore you have an increase in intravascular volume. So but first, I'm not done here, man. After that, when this aldosterone, you understand, gets sodium to be reabsorbed alongside with water, what it does is that the same angiotensin 2, you're like, man, I got a friend somewhere else that we can help us in this condition, you understand? So what happens is that it goes to the posterior pituitary gland. The posterior pituitary gland it goes to the posterior pituitary gland. And when it goes to the posterior pituitary gland, what is found in the posterior pituitary gland, guys? We got the vasopressin in the posterior pituitary gland, you understand? At this point in time, when the angiotensin 2 gets to the posterior pituitary gland, and then there it usually stimulates the synthesis of ADH, man, and ADH will be transported back to the kidney, understand? And ADH will now come to the kidney, and the kidney also lead to further reabsorption of water, man. It's called antidiuretic hormone, guys. Antidiuretic hormone. Antidiuretic ADH. Antidiuretic hormone against it says it's against the losing of fluids.